Hi guys, Mr. Boyle here with this week's video. If you look at the problem up there, you'll see we have a problem. We can't use tangent to solve this problem. We don't have both legs. So how are we going to do this? That's what today's lesson's about. I'm Mr. Boyle. Are you ready? Hey guys, Mr. Boyle here with this week's video. And today you can see we have a little bit of a problem right now. If you watched the videos and did the worksheets from last week, you know that we have an issue with this problem. I want to find theta. Now, the only thing I've taught you so far is tangent, which if you remember from the old video means the opposite leg divided by the adjacent leg. The problem is we don't have the opposite leg and the adjacent leg. We have the opposite leg and the hypotenuse. So how are we going to solve this problem? If we really wanted to go the long way with this one and use tangent, we could. We'd have to first use the Pythagorean theorem to find our third missing side, and then we could use tangent to find that missing angle. But today, I'm going to teach you a couple more trig ratios that can help you when we have situations like this. First, as we've already talked about, tangent means the opposite leg divided by the adjacent leg. And as we've already spoken about here, we have the opposite leg and the hypotenuse. Well, we have another word for that. That's called sine. Sine means the answer you get when you take the length of the opposite leg and divide by the length of the hypotenuse, which is exactly what we talk about with tangent. It's just looking at two different sides. Now, in this problem, the sine of theta in this problem would be 12 over 13. 12 is my opposite leg, 13 is my hypotenuse. Now, in case you're wondering, is there a cheat sheet for sine? Yes, there is, and I'm going to show you it in a minute. The first thing we're going to have to do if we're going to use a cheat sheet is change it to a decimal because, as you know from the tangent worksheet, we don't list fractions, we list decimals. Now, if I do 12 divided by 13, I get 0.9231. And all I need to do is, just like we did with the tangent cheat sheet, is go to our sine cheat sheet and find the decimal number that's closest to it, and then slide over and see our angle. So let's take a look at our new cheat sheet. As you can see here, the cheat sheet has gotten bigger. We're still going from 1 degree to 89 degrees. But now you will see we have 3. We have SIN, which is the shorthand for sine. Now let's jump. TAN, which you already know is tangent. There is this COS. We'll talk about that in a little bit in this video. Okay, so the way this is going to work is you are going to slide down until we get to 0.9231. Make sure you're going down the sine column. I'm going down the sine column. I get all the way to 45 degrees. We haven't hit it yet. So I go back up here. We're at 46 degrees. Sine is 0.7193. Nope, we need to keep looking. And right around there, you will see that we, of course, don't hit 9231, so we're going to try to find the one that's closest to it. And I believe the one that I think is closest to it is 0.9205, so that's the one I'm going to go with. And if I slide to the left, I see that the answer should be 67 degrees. Let's give it a shot and see if we're right. So here we are. We're back at our problem. I have looked up my cheat sheet. I have figured out that my estimate is that it should be about 67 degrees. Let's see if our computer agrees. And you can see that our computer is telling us 67.38 degrees. And if we did round that off to the nearest whole degree, we would get 67 degrees. So that's how you use sine. Now, the only real difficult part of this is figuring out which trig ratio to use. You don't solve it any differently. You just look down a different column in your cheat sheet. Let's move on to the next problem. You can see that I've given you a typical right triangle. I've given you the length of a couple sides. And once again, we're looking for the measure of angle theta. Now, upon closer inspection, I can see that this is not tangent. Tangent, once again, means opposite leg divided by the adjacent leg. In this case, we don't have the opposite leg. We do have the adjacent leg, and we have the hypotenuse. And because we have the adjacent leg, we can't use sine, because if you remember from our last problem, sine means the opposite leg divided by the hypotenuse. We have the adjacent leg and the hypotenuse. That's not a problem. Our last trig ratio is called cosine. And cosine means the answer you get when you divide the adjacent leg by the hypotenuse, which is what we have here. So to solve this problem, we're just going to set it up the exact same way we set it up on the last problem, but we're not going to use the sine column on our cheat sheet. We're going to use the cosine column. Let's get started. So as you can see, first of all, I used the shorthand. I didn't write the whole word cosine. I just wrote C-O-S. Please remember, once again, a little pet peeve of mine, you don't say cos, you don't say cos, you say cosine, but you can write C-O-S to save a little bit of time. Cosine means the adjacent leg divided by the hypotenuse, which in this case is 8 divided by 10. And when I did the division, I got 0.8, so I added a few extra zeros, so it looks like the numbers on my cheat sheet. So now, once again, we're going to go to the cheat sheet, but remember, we're going to look down the cosine column until we see a number that's close to 0.8000. Let's go to our cheat sheet. So here we are at the cheat sheet, and once again, we are going to go down the cosine column until we get to a number close to 0.8000. So we're going to slide down cosine. You can see the numbers are getting smaller as we go on. And let me keep going, and I think we're there. Now, I see once again that there is no 0.8000, so we're going to have to try to find the one closest to it. And the one closest to it this time, I believe, is 0.7986. That is the closest we're going to get. So now we're going to slide to the left to see that the answer should be 37 degrees. Let's go back to our problem and see how we did. So we're back at our problem. Let's measure that angle theta with our computer and see if the computer agrees with us. As you can see, we get 36.87 degrees, and if we were to round that off to the nearest whole number, we would get 37 degrees. So now we have our three ratios. Here are the three trigonometric ratios. We have sine, which means opposite leg over hypotenuse. We have cosine, which means adjacent leg over hypotenuse. And we have tangent, which means opposite leg over adjacent. If I were you, I would pause this video right now and write these three things down on a piece of paper so you have them at all times. That's all I want to do for this video. I'm going to also make a couple extra videos where I do nothing but just solve problem after problem so you can kind of see how we go through these typical trig problems now that we have all three ratios. And yes, in a future video, I will also be showing you how to use your calculator instead of the cheat sheet, but that will be for another lesson. That's all for today. Please go to the other videos, watch those, and then try the worksheets. I'm Mr. Boyle. Bye-bye.